right. All right, Craig, take it away.
Okay. On a continuation on kind of the demos I've been giving, I'm going to continue on exploiting Windows Service misconfigurations. And today I'm going to look at a misconfiguration where a non-privileged user is able to change the binary path of the service. So this one, actually a very famous example, I believe it was, I looked it up, CVE 2010-2729, a vulnerability present in XP Service Pack 2, and I believe Service Pack 3, but for sure 2, with the print spooler service that was able to be edited by non-privileged users. So in this demonstration, I'm going to edit that path and let it run the command that I want it to run. And so what I'm going to do, how you find these misconfigurations here would be using access check from sysinternals. I'll go ahead and bring that up, give Mark Rasinovich a shout out because his tools are amazing. So access check will check the level of access and permissions for given accounts or groups on Windows secureable objects. And so, yeah, it's from the sysinternal suite. So if you're not using this and you're going after Windows machines, you're really missing out. This is a great collection of utilities. But today I'll be using the access check. So I'm going to kind of show about what's going on here in this command. Clearly the access check executable. The switches, the W is finding writable objects. The U just suppresses any kind of errors. The V shows a verbose output, so we can see all the information about it. And the C is telling it to look at services. So this is where you would tell it a service or a file or a folder, directory, whatever. Today we're interested in services. This is actually the user account name. The user account name is user. And the all just tells it to look at all services. And this just accepts the end user license agreement. I've been burned by not putting that in there and the command not running correctly and it, kind of banging my head against the wall. So now every single time I run this, I go ahead and just tack that on at the end. So again, this is going to run it to check the user access against all services that he can write to. Okay, so here is the output. As you can see, read, write, DACL service. And, read control, they can start and stop the service. The biggie here is service change config. That's the big one. And I'll go ahead and pull up a Microsoft documentation for that, just so we can see. This grants the rights, the caller, the right to change the executable file that the system runs. Please only grant to administrators. Well, that's user. As we can see, this user is not an administrator at this point. So what we're going to do is take a closer look at that service. CQC. So here's the DACL service. And this is what we like to see. It will be running as the local system. And this right here is what we're going to edit, the binary path name. And that's what that previous permission had said that we could do. So let's go ahead and just grab that command to save me from mistyping and doing a typo. I'll just go ahead and copy paste, clear the screen. Okay, so right here, this is just changing the configuration of this service, the binary path name, as we just saw. And instead of the binary that is actually running the service, we are going to just run a command to add the user to the administrators group. So we went ahead and changed the configuration. Let's see, QC. As we can see now, right here, when the service starts, instead of running the executable, we've now told it to go ahead and just add this user to the local user. Let's go ahead and just verify in that local group. Administrators, as we can see, the members are administrator, Jasper, that's it, not the user. We'll go ahead and clear the screen. So we're going to start the service. It threw an error because it's not really starting the way that it wants to start. But now we can check the local administrators group, and we can see that the user has been added to the local administrators group. And if we're being clean about it, we'll go ahead and once we've done our dirty work, go in and just, oh, that's not it. We're going to go ahead and set it back to what it was prior, kind of cover our tracks a little bit. SC, QC. And now it's back to running the service. So we got in, changed it, added ourselves to the administrators group, and reset the service since we had the permission anyway, back to what it would be to try to hide what we did here. The remediation for such a thing, services should not be configurable by non-administrative users, especially ones that are running with elevated privileges like system. It can be very dangerous in that situation. That concludes my demonstration. Is there any discussion items?
Yeah, so going back to your access check command, so the argument you gave there was to make it look for writable services. Was that correct? By that, the users group?
Yes, sir. Yep.
Okay, gotcha.
So just one thing I want to bring up, so I've seen this in different engagements. So the services have a user account they're attached to that they run as. So I think it's like SC query actually prints out the user it runs as. But you can change the user that the service runs as without giving credentials for new users. So if like it's set to use like a network service account or something, you can tell it to use the system account. And you can modify that with that scconfig command too. So you can do like scconfig, whatever, and then obj equals the user account you want to run as.
Okay, so you're saying in this case, it was already a system, but if it was not a system, are you proposing that you could actually change that to run as a system if you wanted, or any account that you want?
Yeah, so like say you had like a web service in the box, it'd probably be running as a network service, and the network service doesn't have surprisingly enough permissions to like do like an NC, like run netcat to connect to something else with the network stack. And so like modifying that user is actually pretty important. So if you do like a SC query, I think that's what it is, and then the service name. No, maybe it's the SCQC. It usually has like a username that it sets it to run as. I don't remember the exact command for it.
The start name right
There
here?
it is.
That's the start name's local system, but it's not the start name. So you can change it if you do scconfig the thing. Space obj equals. And then you can do quote nt space authority / system. Get rid of that space there. But yeah. Yep, end quote, enter.
You need a space after your equal sign.
You're right.
See, this is how you know when you do a lot of pen testing, Craig, is like we know all these weird, gotchas for the syntax.
Yeah, I don't know what's up with that, but that's been me before too. So thank you.
Yeah, so now just redo, yeah, that one. Yeah, see now the service name is NT authority system. So now you're actually running as a system account. So like I've been burned a few times, like I've had modifiable services and I couldn't do anything with it. I'm like, what the hell's going on? And it's like,
Yeah,
oh,
no, that's
change
a
the
good call.
process.
I mean, finding that in the first place, you could modify it. I mean, I just showed modifying the binary path, but to your point, you can modify anything in here if you need to, right?
Yeah.
Yeah.
And then sometimes there's also flags they add. So sometimes services will add like tac whatever at the end of it. And so your net user command will fail. And so one of the things I've been doing is just doing like ampersand echo at the end of it. And then it echoes out the tac commands.
So Mike, I'm curious, have you ran into these cases of installing these services, real legit web network services? And I think for some of those cases I've seen, the installer will give you the option of creating your own kind of account to run it as, and then adding a password as well. So I'm wondering, is that like, are they scripting that mechanism in terms of either creating an account or adding a password to your account, because like you're saying, like things like network services, they don't by default have a password, right?
So network service accounts, like when you run unicats, like it prints out like this giant wrong character string of a password that the network service account got added to.
Okay.
So I don't know where it's getting it, how it's generating it, but like
Mhm.
there is a password that gets assigned to like service accounts.
Okay.
Um,
Interesting.
But yeah, it's like handled on Windows Magic on the back end.
Okay. Yeah, because I think yeah, for one of these images I had to create for the CTF competition, I was installing these different services, and then it asked, do you want to use the default, I think, network net login account to run the service, or do you want to create your own, which I think they recommend, to run your own service with your own sort of account for that service. So, and you know, I don't know how that works on the back end for Windows. So
Yeah, I mean, honestly, I don't know either. Like it's a whole different exercise in itself just to try and learn that piece.
yeah.
That's one of the tricks I've learned over the years, just like double check that user and double check the what flags they add at the end of your binary command. Like if you modify the binary command, you have to modify the flags as well, or handle the flags.
Cool. Awesome. Nice, Craig.
Sweet.
That was awesome, Greg.
Yeah, no, appreciate it. And thanks, Mike, for coming in to be all-knowing and adding some crucial details. I really appreciate that.
Okay, so a fun trivia question for the group here. Do you guys know the difference between DACLs and sort of other kind of access control models by any chance?
That'd be reaching way back in the memory. I guess maybe I don't understand the question, or don't
Sure.
have that
Yeah,
information.
it's kind of weird. Dave, do you have something?
So are you asking for the difference between like discretionary access controls
Yes.
and other access controls? I
Yeah,
don't know.
totally. Yeah, that's what I'm asking.
I've been in programming and assembly for school, so my brain is mush, but are you referring to like events that have been generated that would like, oh, okay.
No, just like you're saying. So number one is what does DACL stand for, right? That's discretionary access control. And so in in computer science class with cybersecurity, the two big models that they used to have is mandatory access controls, right? And DAX, discretionary access control. And then one of the big ones that popped up on the scene was a role-based access control. I believe a lot of cloud environments are doing that. But traditionally, I don't know how modern Windows work with these different access control models, but discretionary, it means if you're the owner of that object or you have permissions on that object, you're able to give other people permissions. So if you're a system admin, the ability of you to sort of audit that, just like who has permission to this, it becomes really unwieldy, because like if Dave has permission, it's like, okay, I'm gonna give it to like all these other people that I want to give permissions. And if I was the original owner, it's like, I thought only I gave permission to Dave, but Dave gave it to a bunch of other people. I think with mandatory access control, it's way more strict in terms of like there's like a central person who gives the access control, and it's all in one place. So so even though if I give access to Dave, you don't have permission to give it to other people. So I think at a high level, that's how it works. But I would have to do more research in terms of how Windows itself does that. So yeah, I just wanted to share that.
No, that is it, Andy. That's why you got to be careful giving these permissions. Like I said, don't just give everybody full control if they just need to read the objects, because then it can get out of hand quick.
Yeah. Okay. Awesome. Start the recording here. All right. So I'm gonna do my demo. It's gonna be on the Frida instrumentation library. So I'm going to first, let me see, what should I do first? Oh yeah, this is gonna be super simple. So I'm gonna first pull up my script here. So this is a library that I'm going to be used. It's super powerful, but for this demo, I'm just gonna show some very basic functionality. So first off, right here in Python, we just have a simple function that will print, you give it 2 arguments, it will print first the message and the data argument, right? So how does Frida work, right? So Frida has the syntax of being able to attach to different processes. And in my case, I think I'm going to attach to the cat. So I'm gonna run cat and then I'm gonna attach to it. And then you have this script block right here. So in this script block, I think what it's doing here is it's going to enumerate all of the modules, so all of the imported libraries associated with this process, the cat process, and then it's going to enumerate that, right? And then it's going to give you back a list. And then so that's a script. And then so the next function call here is, okay, let's look at it. A mess. Okay, so it looks like message associated with a message function, and then it loads the script. And then finally, at the very end here, it iterates through the running of that script. So you're going to have a list of all the modules for that particular processes, and then it's going to print. So that's what this simple script is doing. So I'm just going to show it. So first I'm going to run the cat command, right? So cat is running as a process, and it's just sort of, just running there waiting for input from the user. And then I'm going to run my script, Python fe Python, and there. That's it. It's not that sexy right now because I'm sort of just beginning to learn it, but basically it print out the list of all the modules associated with that cat process. So we're getting these libraries, these what do they call them? I guess dynamic libraries in these dynamic libraries in Linux. But I think a few of these libraries are also associated with Frida as well. But the question I kind of have, so let's see which cat, right? And then one of the commands I know to get libraries is LDD, right? So with LDD, I get some of this. So, okay, that's connected there. But this one, libc so6, that doesn't show up in my listing. I think that would be the equivalent of libc. I'm guessing that's what this is right here. And yeah, but then, there's a few of these other ones that doesn't get caught up by LDD. So for, according to these different tools, I'm seeing sort of a different set of outputs. And I don't know enough about these different modules to sort of know exactly why these different tools give these different outputs. So yeah, that's in a nutshell sort of what I got it working so far. Hopefully in future demos, I will be able to do more powerful features of Frida. Frida has some really amazing capabilities. And unfortunately, a lot of the tutorials, they share how to use it with Android emulators. So they use it to reverse engineer and introspect Android. And so, for the next time, I'm going to have to get that working in my environments. And hopefully I'll be able to share some more powerful features of Frida. But the little bit I've seen of it so far, it looks really, really cool and powerful. So, that's all I had. Any comments, questions? Okay.
So I have a question.
Yeah.
So this is just analyzing the headers that the cat program has in terms of its binary and being able to link it back to this library?
So that's sort of a really good question in terms of, you're sort of trying to figure out how it works, right? So no, it's not looking through the headers in terms of the way you think, you compile a program and it has header files, right? I think this is what it's doing right here. First, it's attaching to the process, right? So, in Linux, right, if you run PAUX, and if you had, my cat's still running, yeah, grep, I guess, right here, grep kfan, oh, geez, right here. So this is, the process, the ps command lists all the process. So it's using that kind of mechanisms to attach to that process. That's how it's attaching here, right? And then after it attaches, it's using these very powerful libraries. So right here, this is a process library, right? So it's jumping into, I think it's reading the data structures that is associated with that process to get all of these imported libraries, right? So, and that was the output here. Let me run it again really quick here. Right here, right? So these, my guess is these are all the imported libraries that this process is using. So that's I believe that's how it's working, right? It's doing it in real memory. But the reason I really like your question is that Frida and a lot of these other reverse engineering tools, they all also have the capability of, if you just have the binary on disk, right? So for instance, bincat right here, this is the file on disk. So there are other mechanisms of introspecting it by reading I think in this one, it's the L file, right? It's going to read the L file, and based on decoding all of the different headers within the L file, then it can figure out all of the imports that way as well. So that's sort of another way of sort of trying to figure out on disk, if you have a binary on disk, versus the way I did it, which is introspecting the process in memory, right? So
Oh,
yeah, very cool.
awesome.
Thanks. Okay.